My name is Farouk. I work at Kunga. Let me sort this stuff out quick. Hey guys, so today I'll be going through the basics of machine learning. How many people here are taking a MOOC course, Coursera Audacity learning of machine learning? Show of hands, please. How many people? One, so 2 people. Okay, so this should be a very basic class, so I think I have the right material. Just some details, blah blah blah, from the ask me on Twitter. Okay, so machine learning. And what is machine learning? So the answer you get depends on who you ask. So some will say it's mostly pattern recognition, trying to generalize from data to some unseen data. But I think the common one that I've come across this time is basically you are giving the computer the ability to learn by itself without programming it. So, do you get that definition? You get it right? Yeah. So basically, you want to start to act without you telling it what to do. So we have some practical problems that machine learning are very good for. So for example, we have fraud detection, face detection recognition, there are different things. So detection, you want to know if these objects are looking at the face. Then recognition, you want to know if that face is you or somebody else. Then machine translation is basically, language. You want to convert Chinese characters to English or to French. Then spam detection. This one is I think most common. So the way Yahoo does it in your inbox, pushes some emails to your spam, or put them in your inbox. So for product recommendation, I think we have seen this also in play. Yes, Conga is Junior is a ton of e-commerce stores. They use this to recommend products to us where you visit their website based on our browsing history, what they think we like, based on our actions, what we click, what we over on. So they use that. Then driverless cars, in the case of Google and maybe Tesla soon. Those are some common uses of machine learning. There are others. They are using cancer detection. When you go for a screening in UK or US, or basically any first world country, they use this to screen you to see the probability of having cancer or not. So they do that. Alright. Well, prior to this hype of machine learning, I know I've met a few programmers who argue that it's basically just if else dismiss. So why can't you write a program? If this do that, else do that. So why can't you? Anybody? So why can't you write your program in say JavaScript? You do if else this, if not that, you do that. What? Get boring. I said not necessarily boring. It's not really boring because it's a very difficult task. So okay. So this is a real problem. This is data from Kaggle. I think this is there's this insurance company. They want to know if a prospective customer will buy a policy. So this is data they feed into the machine learner. to determine. So, yeah, this field right here, so the zeros mean no, then the ones mean yes, the customer will buy the hotel policy. I mean, that's working with. If you have to do this, using Java or Python, I mean, how would you do it? If field 6, with this, if field 7, it becomes very difficult. For example, this particular data set has about 299 features. And this is just small. I mean, I've seen some data that has about 1,000 features. I mean, there are some that are 10,000, millions. It's very possible. So you can't do this as a program. I mean, you can't say you write a computer program that will do if this, if else that. It's not possible. So you have to, be at one with that. You can't do this using your typical program. You need machine learning to do this. So that's it. So basically, we know that machine learning does what it does, basically by learning on data, historical data. So this is how it does it. I mean, you need the data, you need data from somewhere. So say you're trying to do facial detection now. So basically, the way that works is, you need to convert that image, if it's black and white or if it's colored. So if it's black and white, you need to convert that image into the pixels. Basically, an image is made up of pixels. So, and if it's if it's colored, it's going to be width, depth, and height because it's 3D. So that's your data for face detection. Then you feed that into an algorithm. There are many algorithms to get that data. Feed that into an algorithm, and then you optimize what the algorithm learns using the loss function. So basically, for machine learning, you need three things: you need the data, you need the algorithm, and then you need the loss function to optimize against. So these are a few terminologies. So we have features. So the features are basically distinct traits that characterize a data point. So say, for example, I want to write a classifier to determine if rain will fall. So now the problem is, will it rain or not, right? So I need features for my machine learning problem. So the features now will include, is it sunny? Is it cloudy? Is it windy? Is it stormy or humid? So those are features. So the features are distinct traits for the problem they're trying to solve. So those are features. Then the samples or data points are just the data sets you have to work with, different data points you have to work with. Then the feature extraction is you extracting features, extracting the traits from data. Then, so part of the machine learning workflow is to divide your data set into a training set and test set. So you train your machine learning algorithm using the training data, and then you evaluate its performance on test set. So goes to there. I mean, there are lots more terminologies, but I think we should stick with that. You stick with this for this class. Then, so the workflow for machine learning. I mean, I should have had a pretty picture, but this will have to do. So step one, after you extract your features from some input, you would train the learner classifier. There are differences, but most times they use interchangeably. Then you evaluate performance of the learner using the loss function. We will get to that. And then you optimize the hyperparameters of the algorithm. And then depending on how the results, does go back to step one, or you start using it in the wild. Okay. Have I been talking to myself since? Mostly yes. You guys didn't get it. Don't worry, it will be easier with time. I'm trying. Okay, so there are different types of machine learning based on the labels data, and then based on the techniques used. So ML based on label data is supervised, unsupervised, semi-supervised, and reinforcement learning. So for supervised machine learning, so basically you have data that has been labeled. So say you want to predict if it will rain again. So you can have this sort of data So these are features: sunny, windy, cloudy, thunder. Those are features. So this literally is a label. It's telling you the corresponding class of each data point. So for example, for the first data point, is it sunny? Yes. Is it windy? Yes. Cloudy? No. Is it thunder? No. Will it rain? No. Yeah. So that last column is the label. So you have a data point which consists of features. Then you have a label. So when there's a label for each data point, it's called supervised machine learning, right? So when it's not labeled, I mean, you can see here you don't have a label. That's unsupervised because now your algorithm doesn't know which class each of these data points belongs to. It just knows that you are giving it some data point. Yeah, I mean that is the distinct feature between unsupervised and supervised. Sorry, this is the wrong title. This should be semi-supervised. So this should be semi. Okay. So there are four: supervised, unsupervised, semi-supervised, and reinforcement learning. So I think I missed the slide for semi-supervised, but I'll just go through it. So with semi-supervised, some of the data points don't have a label. So imagine, for say, this data point, this label was missing. So basically, some points have labels, some don't have labels. So that's a semi-supervised machine learning problem. Then the last one, which is reinforcement learning, we won't do that today, maybe some other time. So basically, it involves rewarding a machine learning algorithm based on how close it is to solving a problem. It's used mainly in, it was used in the match against the Korean Go player. It's used in Google cars. It's used in predicting stocks. Not really a basic technique. So, yeah, then based on techniques now, the one we talked before was based on legal data. It's based on if data is legal or not. So based on techniques, we have classification, regression, clustering, and then dimensionality reduction. So for classification, you're basically trying to detect which class a test data belongs to. So say in the example before, the one for the weather, trying to predict if it will rain or not. So say after you've trained your algorithm, I mean basically it's a classification problem because there's a class. Well, there are two classes. Will it rain, yes or no? Those are your classes. So yes or no are your classes. So you're trying to classify the features into a class. So that's your classification problem. Other examples include, trying to detect if an email is spam or not. That's classification. Then trying to detect if a transaction is a fraudulent one. That's also classification. Then the algorithms that are mostly used in this for classification includes decision trees, random forest, ADA boost, XG boost, naive classifier, nearest neighbor, and neural networks. The most popular, the ones that I've seen most used with classification, at least from my experience, is usually trees. They do a lot of wonders. Then for regression, this usually involves trying to predict a continuous value. So say, how much rain will fall tomorrow? It's not 0, it's not 1, it's usually, there really isn't any bound between, when I'm trying to predict how much rain will fall tomorrow. It can be 100, it can be 2,000. It's on a continuum. It's not distinct. It can be anything. So that's regression. Then also, say how much you really get on an investment. It's not A, B, C, or D. It's whether 1,000, 2,000. It can be anything. So that's then, for example, you could have written an algorithm to predict how many people will show up for this meetup. Yeah, so that's also regression. The algorithms under regression include, absolutely linear regression. I think we have done this during our start course, somewhere, secondary school, university, we have done this. And there are also regression trees. then neural networks, and nearest neighbor regression. So for clustering, so one thing you should know is classification and regression usually are supervised. I mean, for the most part, they are always supervised. But then clustering, on the other hand, it's usually unsupervised, because what they're trying to do is trying to figure out the groupings of your data. So say you have the data sets now. You don't know the labels for the data, but you want to group the data points into clusters based on some similarity feature. So that's basically what clustering does. And it's used most times with marketing, genome sequencing, where you try to group things. So for example, if you are doing customer segmentation, say for example you are Junior Yakunga, you want to group your customers into segments. So you can have like 5 segments. So these segments can be your high value cluster. Some other segment may be maybe these set of users. You only spend between 1K and 5K on your shop. These other cluster spend like 10K and 20K on your shop. So basically, you don't have a label for the data. We are trying to see if the algorithm can come up with a cluster from data set. Then also, you can also use it to categorize those articles. Say you have some articles, you can group them into categories. Say, okay, all these are sports, all these are politics, all of these are comedy, stuff like that. So for the algorithms under this, we have K-means and mixture models. Then for this dimensionality reduction, basically what it does is it tries to reduce the number of features without losing information. So for example, say we have this problem now. So this data set contains about 299 features. That's small. But assume it has about 20,000 features. That's a lot. So, sometimes you might not have the capacity, the infrastructure, the competence to work with such a high dimensional data. So what you want to do is to squeeze, to reduce the number of features from 10,000 to say 5,000. Something you can work with much more easily without it losing without the data losing its meaning. So you want to reduce the number of features without data losing meaning. That's what dimensionality reduction. Then the tools that are mostly used, so Python or Scala. Anyone know R? You know R? Good. So there's R. And the most used module is usually scikit-learn. Then there's Reka. There are lots of modules you can use. These are just examples. And then, so if you want a much more in-depth understanding of machine learning, these are some resources I recommend. Coursera University have a lot of good resources on machine learning. Yeah, so questions? Yeah, very short. Questions? No questions. So you all got it right. You have a question? Okay. Let's go. You want the mic? I can hear you. I can hear you. Okay, so he asked how machine learning is different from data mining. Well, machine learning, some have argued that when start machine learning, how different are they? So they are similar for the most part, but then there are also some differences, especially when you have to deal with, say, training a model. All of that. There are differences between data mining and machine learning. So, for example, there's this popular technique. It's called rule-based association. That's a data mining technique. it's not really machine learning. So if I were to explain it, I'll say there really isn't any learning in data mining as opposed to machine learning. Does that make sense? It does. It is right. What? Oh, okay. All right. Anyone else? Sorry. Yeah.
But is there a range of
yep.
Like when you're doing features, you're doing something regarding features, they can be just characteristics your algorithm look into to actually learn something.
Okay.
So I'm just curious, is there a limit or some certain range, or when is the data, how much data does an algorithm need to actually learn? You understand?
Yeah.
The feature range.
Oh, yeah, very good question. Sorry, time out. Yeah, I'm time out. So, yeah, very good question. So, so it has how much data does the machine learning algorithm need? It makes sense. So, I mean, typically, you want to use a machine learning algorithm and say in data points with 100, or 20 data points. I mean, doesn't really make much sense. So it's usually used when you have like a short problem. So you have like, say 1K data points is, I mean, that's a good threshold. So say 1K. Yeah, 1K is fine, but there really isn't any hard limits on it. So you have 1K data points, and it doesn't really matter for the features. I mean, you can have 3 features, you can have 5 features, it doesn't really matter. But then for the number of vectors, for the number of data points, I mean, it should be substantial. Are you fine with that? Fine. Excuse me. Yeah. Yeah. What difference between machine learning and
Can you wait for the mic?
No. I can't tell.
For everybody to hear.
Okay, all right.
Okay, my name is Peter. I just want to know what's the difference between machine learning and artificial intelligence that we used to know before? Are they related, or is there a special branch of AI?
Yeah. Machine learning is a special branch of, machine learning is a branch of AI. I mean, it's a subfield of AI. So, I mean, under AI, you have robotics, and then you have machine learning, and then you have some other fields. It's a subfield.
What's the difference between machine learning and
what's the difference between machine learning and deep learning?
Okay. So, deep learning is a technique used in machine learning. It's just one of the numerous algorithms. Yeah, so don't let me throw you. So deep learning is basically neural networks on steroids. That's what it is.
I have a question. Alright, so sometimes I try to feel smart and then I have a lot of buzzwords. I tell my friends, like my friend was like, you can say hidden Markov models and then Bayesian graphs and neural networks I mentioned now.
Yeah.
Are they all how do you classify those algorithms? Basically, those are algorithms, right? But are they classification algorithms or what exactly?
Yeah. I think your question is related to advanced for this class, but I'll answer anyways. So hidden Markov models are graphical models. Same thing also for Bayesian networks. You all know the Bayes theory, right? Bayes theory.
No, we all don't know it.
Really? Yes, engineers, how you know Bayes theory? So, okay, maybe you forgot it, but I'm sure you did in secondary school or university. Maybe you forgot it, but I'm very sure you did. Yeah. Okay, so Bayes rule. I'm looking forward to explain Bayes rule. So, okay, I want to explain Bayes rule. Yeah, so hidden Markov models and Bayesian networks, they are graphical models, and they are a subset of the But most times they are under semi-supervised learning.
Okay.
Because they know how to handle data that has missing labels very, very well. But also, I mean, you can use them, say, for classification or regression. Now, so there's something you should also know about. Let me check. If you notice in the slide, say here, I have classifier trees here, and then I have regression trees here. So, for example, trees. So basically, the algorithm is called trees. You know, it's tree-based. So you have a tree. If this go this way, if that go that way, if this come here. So basically, it's a tree. So the thing is, you can use them for classification or regression. So an algorithm isn't usually restricted to a technique. I mean, you can use them for also neural networks. Also appears under classification. Same for nearest neighbor. So I mean, sometimes some algorithms are not exclusive to a particular technique. I mean, you can do so many other things.
Any other question?
I wanted to ask, what kind of machine learning is used in high frequency trading?
Yeah. Depends. I mean, we use anyone. But you want to use nearest neighbor. You want to use something, time series. So it's called time series in statistics. So high frequency trading basically tries to predict stock returns. That's what it does. And the stock return data is a time series data. So this happened today, this happened tomorrow, this happened next tomorrow. So it's time series. So I mean, you can use any time series algorithm. You can use decision trees. You can use neural nets. I mean, I've seen neural nets being used with frequency trading before. Then also you can use reinforcement learning. The other part of machine learning based on the label data. So you can use reinforcement learning. So basically, you will reward the algorithm based on how close it is to a solution. Yeah. Any other question?
Please, can we get the slide?
Yeah, it's shared. It's somewhere. Yeah, you can get it.
Yeah, slides will be available to everyone. Yes, one.
Hello, my name is Wayne.
I know you are.
So my question is very simple. So a lot of my foray into attempting to do some machine learning question and stuff, I basically summary that I figured out it's a lot of mathematics. So what are the fundamental mathematical courses that say a beginner needs to probably take to be able to make him understand some of these things faster? Like, I skipped a lot of math class, so like, what do I need to catch up on?
Yeah. Very, very good question. So you need base rule. So this is base rule. If you don't know base rule, so this is base rule. So basically, when you're So essentially, what this is saying is, I want to estimate probability of A given B, and then you just put around. Yeah, so this is the issue. So you need probability, you need statistics, you need linear algebra. Yeah, so those are the things you need, like the basic maths you need. So probability, statistics, and linear algebra. And linear algebra, you need your matrices. You need them. Eigenvectors, eigenvalues. You need all of that. I mean, so the thing is, you can get by without knowing all these things. I mean, it's very easy. Just get a library. I mean, scikit-learn or Baker, and then just call the library. But then you won't really understand how these things work. So I mean, for you to understand how these things really work, I mean, even for you to get a job in machine learning, because I mean, I expect the RA guy to ask you to explain the theory behind these things. So you need probability. You need visual, a lot of visual. You need it, and linear algebra.
Any other question?
Any other question?
Thank you. Thank you. Okay, that's right.
I'm sorry, when you guys like, you made mention of Conga and Jumia, how they recommend for you. And that's two I can remember that you made mention of. I have a friend here, he does SMS. That's the one too, he does SMS. I have a friend that is doing predictions and all of that.
Okay.
So I'm just asking, apart from e-commerce, what other areas? I mean, a lot of Nigerians do e-commerce sites, we do SMS sites, we do a lot of apps. So how can I use this? You know, how can I use this? Or the guy is starting out building his app that will allow his friends connect or chat. How can they use machine learning to help better their solution? Somebody asked, are we ripe enough to use machine learning?
Yeah, I mean, that's a very good question. So I think that's the question we should ask before trying to use the machine learning solution. So, I mean, Nigeria is ripe enough for machine learning. I mean, of course, you want to compare Nigeria to the US or to UK, but Nigeria is ripe enough for machine learning. I mean, there are problems. I mean, you can solve using machine learning. But you can't solve traffic using machine learning. There's no, you can't solve traffic. Traffic is infrastructure. So say for example you were building an app, I mean say social network stuff. I mean Facebook, say you're building the next phase of Facebook 3.0. You're going to need you need to connect your users, right? I mean, okay, hey guys, do you know this guy? Meet this guy. Yeah. So you can use recommendations. So you are recommending user BCG to user E. So I mean that's recommendations. If you use machine learning to make recommendations, I mean there are metrics, factorizations, methods you can use to do that. Yeah. But I mean, not every problem requires machine learning. You should know that. More questions?
Any? Okay.
Okay, thank you. My name is Blaze. Basically, I want to ask about the hardware experiment as regards machine learning, because we're dealing with a whole lot of data. Probably you have a value in the system where you're pulling from cloud or AWS. So your system or server, so what do you have to say about the other requirements, and then in conjunction with this Nigeria for it, we have the resources to go there, talking about internet access and
Okay, thank you. So the hardware you need will depend on the problem you're trying to solve. So and likely to depend on the amount of data you have. So, say for example, I mean, you're working with terabytes of data. Of course, it don't fit on your single machine. You need like a cluster of machines to make it work. And then the much more difficult your pipeline will look, because now you can't fit all of that data into memory. You have to create a stream. So things like Spark. So there's this stuff called Spark, Apache Spark. So it's basically distributed computing workers. So it does a lot of stuff for you. But say you had 200 megs of data you want to work with. That's fine. I mean, that can fit on your 40-gram machine. So basically, when you have more data than RAM, they know you're in trouble. I mean, you can't fit 10 gig data on your 80 gram. You're asking for trouble. Yeah, and one of the ways to work with this includes, so you sample the data. So say you have 1 million rows of data, then you sample the data. Because, I mean, it's too large to fit into your memory, so you sample data, you say you take 100k rows at random. But then you have to make sure that the point you take represents the population. Yeah. So, but then say for, I mean, I've seen people work with 4 gig RAM, Wi-Fi, and that's fine. But usually, I mean, I do most of my work on DigitalOcean or AWS. So I basically spin up, say, a droplet with 32 GB, 16 cores, and then do stuff. But then when you're at Google scale, you want to use DigitalOcean. Yeah. So, last question. Last question. Last question.
Okay, I'm just curious, probably as a software developer, so like what can we find that requires you to build a system to actually predict on length stuff? How do you work with the client, like getting the right amount of features to actually do your machine learning stuff and code?
You ask very interesting questions. Yeah. So, if I get to it correctly, so basically it's feature engineering. So feature engineering is what they don't teach you in school. It's very, very hard. So, I mean, some people say feature engineering is the black hat for machine learning. I mean, it's not. So basically, when you're doing the feature engineering, you need domain knowledge. You need to know the domain very, very well to know which features that are very relevant. For example, say you want to build a solution for a hospital, say for cancer screening. I don't know cancer. Do you know cancer? You don't know cancer. So you use to consult with some doctors. So to put you through what to look out for, how to read the mammograph. I mean, what features make a cancerous patient. So you need domain knowledge. And feature engineering is very, very hard. Like, difficult, but it's not undoable.
Yeah. Rolling back to the earlier question, you mentioned Konga Junior and keeping hotels. Some time ago they did a hackathon on machine learning. And my interest was drawn to that, and I wanted to know, at what point would your business startup, anything, get enough data where it makes sense to implement machine learning?
Okay.
And then when is it viable financially, commercially to do that?
So, I mean, I think one way to go about this is when existing solutions don't make your business any better. I mean, I think it makes sense to try whether it is a good place to start, but then don't expect a huge return on investment. I mean, it's just one key. Yeah. Does that answer your question? When is it worth the investment? Yeah, when you make plenty money, it's worth the investment. Yeah, I mean, so basically, I mean, when you make more money than you invest in the solution, I mean, I think it's worth the investment. So, okay, well, I mean, basically, you do your research. I mean, you see what other people in your space are doing. Yeah, if you have, I know you have, like, look at my faces. Some of you look confused, so if you have questions, shoot me an email or tweet at me. I like tweeting, so I'll respond. So thank you very much.